a instrument. In this, if you divide this term, that is digital, as a one term and your multimeter as the other term, digital in the sense we are going to get the output in the digital format. What is your digital format? 1, 2, 3, the numbers, right? We'll be getting a digital display. What about your multimeter? Multimeter in the sense a particular instrument. We are going to take a particular instrument. We are going to measure something. But in this measuring instrument, we can use it as a multi-purpose instrument. We can use to measure your current. We can use it to measure your voltage. We can use it to measure your resistance. Okay. So this is the general view of your digital multimeter. Means we are going to get an output that is in a digital format, digital display, and it is used in the multi-purpose environment. Means that it can be used as your ammeter. We can get the value for your current, we can get the value for your voltage, and we can get the value for your resistance. Okay, this is a general overview of your digital multimeter. Now we will get inside what exactly a digital multimeter is. So as I told earlier, it is a tool to measure two or more electrical values. That is what I told you earlier. It can be your voltage, current, or resistance. So these volts, it is a voltage can be measured with turns volts, in ampere, and in ohms. Ohms is for your resistance, right? Okay, these are the standard tools, and this is basically used in all your electronic labs, laboratories, right? It can be used in shops. We can find it. It is very easily available in shops. Okay, this is what your multimeter is all about. Okay, fine. Now you can see a picture of a digital multimeter. Okay, in the marketplaces we can buy like this kind of multimeters. So this is how it will look like. Okay, so in this picture you can see a digital display. I mean, it is your display. It is a LCD screen. Okay, this is a LCD screen. This is a display over which you can find the values of your current. We can detect the value of your voltage or resistance. Okay, actually in this display, it is a 5-digit display. The display is all about 5 digits. Okay, means that just imagine the digits are like 1, 2, 3, 4 and 5. Okay, see, in this the first digit represents the sign. It might be a positive or a negative value, the value which we are obtaining. For example, just imagine we are going to measure the value for your current. So if it is a positive, means that represents a plus sign, and if it is a negative, means minus, right? So this first block represents the first digit represents your sign. Okay, the next 4 digits represents the value of your voltage or current or resistance, whatever you are going to measure. Clear? This is what the structure of your display is all about. Clear? Clear. So display has a 5-segment display. In that, first represents your sign. It gives the place for your sign, the value which you obtained, whether it is a positive or a negative. The following 4 segments says about the value of your measuring unit. Okay, fine. So next you can see a AC voltage range. See, before that we have to know about it. This is a rotating knob. Okay, using this, see, you can place your hands over that and you can rotate it like this. Okay, it is a rotating knob. By using that rotating knob, you can select whatever measurement you have to know. See, you can see some calibration over here. Some values have been calibrated over the circle, right? So if you want to measure the voltage to that particular area, we have to turn your knob so that you can measure your particular voltage. If you want to measure the current, you have to turn that knob so that to that particular area you can measure it. So knob it is rotatable. To place it, what you have to measure, you have to place your knob in that position. Okay, so this is a rotating knob. Okay, now see, over this calibration, what are the values it is found is that, see here, to your right top, you can see a AC voltage range. In order to measure your AC voltage and DC voltage, here is the turns. Okay, here is your area, so that if you want to measure your AC voltage range, you have to turn this knob in this direction. Okay, so that you can measure your AC voltage range. So if you want to measure your DC voltage range, you have to turn your knob to this position, so that you can measure your DC voltage range. Clear? So that likewise, in this side, just see about your left hand side, you can measure the DC voltage range and your resistance range. What is a resistance range? It is represented as ohms. Clear? The resistance is represented as ohms. And now in this, you will be having some terminals. Okay, some 3 terminals. Okay, this is a probe which is see, this is your 2 probes. One is your positive probe and second one is your negative probe, the red one and the black one. The red one is said to be your positive probe and your black one is said to be your negative probe. Okay, and added to that, you'll be having another terminal which is your high current terminal. Means that if your supply, if an input supply is more than 10 amperes, when the input current is more than 10 amperes, then you can connect the probe over here and you can measure your current or current. Okay. And for the lower voltages, see, this is for your positive. The red color probe is for your positive measurement, and the black color is for a negative, or it can be a common terminal. So what are the measures we can measure? That is milliamps. Milliamps, we can measure milliamps, voltage and ohms. Okay, that is your resistance, voltage, resistance. See, these are the things we can measure with your red color probe. Okay, that is your positive terminal, and next is your negative, that is your common probe. Okay, now you have a diode tester. These are the different things which is available in your multimeter. So now we will see the circuit diagram of your multimeter, will understand what exactly the working of your multimeter is. So now, yes, you can see the block diagram of your multimeter. Now, in this block diagram, say, this is going to be your rotatory switch. Means that, what is your rotatory switch, ma? It's nothing but the rotating knob which I told you earlier. You can rotate it in any whatever direction you want. If you place that in particular position, you will be measuring that particular value. Clear? Right. So this is your rotating switch. So this is your rotating switch. Now the input probes are nothing but what is your input probes? That yellow, that is red and black probes are your input probes. Clear? So now, so this is your input supply. Here is your input supply, and next you can see some 5 lines over here. Okay, you can see some 5 lines over here. So this one is to measure the resistance. In order to measure your resistance, this circuit is working around. If you want to measure the AC voltage, ACV is nothing but AC voltage, ACI is nothing but AC current, and DCI is nothing but DC current, and DCV is nothing but DC voltage. Clear? RES is nothing but your resistance, AC current is ACV, and ACI is nothing but your AC current, and DCI is nothing but your DC current, and DCV is nothing but your DC voltage. Clear? Now see, you can see that for resistance you will be having some different kind of connections, and for AC voltage, current, DC current and voltage will be having separate type of connection. So already you know that in your multimeter you can measure both the AC and DC current, voltages, resistance, everything, right? So but in that usage they'll be having a different circuitry. Okay, we are going to see what exactly happens if I want to measure my AC current, if I want to measure my DC current or voltage, whatever. Clear? So in this first circuitry, you can see the will comes from the first one, that is your resistance. If you want to measure your resistance, see, just imagine, just consider your first circuitry. Okay, if you want to measure your resistance, you have to come with your Ohm's law. Ohm's law is nothing but your V is equal to IR. Clear? Ohm's law, V is equal to IR. In order to measure my resistance, R is equal to V divided by I. Am I right? Am I right? Right. Okay, now in order to measure my resistance, I have to know my voltage and current value. Am I right? Yes. So in this area, I'm going to measure my resistance. In order to measure my resistance, I have to know the voltage and current value. So for that purpose, a constant current source, whereas the current value has been given to your to your resistance point. See, this is your constant current source, so that the current value we have obtained, the balance is nothing but your voltage. So the voltage you will be applying, you will be getting from your input power supply. The voltage you will be getting from your input power supply, so that the voltage and current value is available, means that we know the voltage and current value, so that that particular value is get fed into your buffer amplifier, where the signal is got amplified and it is fed into a analog to digital converter. Why it is sending into a analog to digital converter, ma? The signal which is obtained from the amplifier is in analog wave. It is an analog waveform. Okay, it is in waveform, right? So this is get converted into a digital signal with a decoder. With the help of a decoder, it is get converted into a digital segment. Why? Because we can see the output only in a digital format. So it is a digital multimeter, right? Already I have told that we will be finding the output in a digital format. So in order to obtain a digital format, we are sending the analog signal to a digital converter, so that the analog signal is get converted into a digital, and finally will be getting the output in the display screen, that is your LCD screen. Fine. This is the overall operation of your resistance in order to define your resistance. Clear? Now the second one, that is your AC voltage. Okay, now if you consider the AC voltage, again the input voltage have been obtained over here, as regularly it will be getting the input voltage from the power supply. Okay, now it is get given to a calibrated attenuator. See, the main purpose of a attenuator is to, if say for example this particular circuit has a particular level of power consumption. Okay, if the given input is higher than the particular amount of power consumed over here, then this will cause a damage to your entire system. In order to avoid the damage the current or voltage causes, to maintain it in a correct level, we are using this attenuator to make the instrument to work means that in order to avoid the damages which is caused due to the improper supply, means that if it can be a high or a low, if it is very high, the supply current or voltage is very high, that will if it is directly applied to your entire process, this will damage your system. In order to avoid that, you're getting into your attenuator so that it will level the voltage to the required amount, and that is sent to a rectifier circuit. So why it is sent to a rectifier circuit is that here the AC is get converted into a DC supply. Okay, here the AC is the rectifier is used to convert the AC into DC, and this is again fed into a analog to digital converter. So again it is get sent to analog to digital converter, so we can find the output in your digital display, that is your LCD. Clear? So in your AC, in order to define your voltage, it is get sent through your calibrator, attenuator, and from that a rectifier circuit where AC is get converted into your DC supply, and now DC is get fed into your analog to digital converter. The output over the rectifier circuit is going to be analog waves. It is going to be your waves. Okay, so it is going to be a wave, so that this is get fed into your analog to digital, so that this is get fed into your analog to digital, so that this is get fed into your DC supply, and now DC is get fed into your analog to digital a converter, and then to a display, that is your LCD display. Clear? Now getting back to your AC current. Okay, now again to a AC current. Here current to voltage converter is nothing but the shunt resistance, low shunt resistance. Okay, so here from the low shunt resistance, it is get connected to your rectifier. The same thing is happening here also. AC is get converted into DC. Again it is fed into your analog to digital converter. Finally with the help of a decoder, will be getting your digital display. Clear? Now this area is a low power shunt. Okay, low shunt resistance. Low power shunt, low shunt resistance. From there it is get connected to your resistor rectifier circuit. What is the purpose of a rectifier? Yes, please write the answer in the comments. Right now I'll say it is used to convert your AC into DC. Clear? Fine. Then it is fed into your, the DC supply is get fed into your the analog to digital converter, and from there we can obtain the output, that is your digital output. Fine. Now next you can see your DC current. Again DC current is get to a, here also it is a current to voltage converter, is nothing but your low shunt resistance. Okay, current to low shunt resistance. Again it is get connected to your directly to your it is, there is no analog to digital converter. Why? Because the signal directly it's fed from your input current, and it is sent to your analog to digital converter, and finally you will be getting your display. And in the final thing, that is your voltage also, it is given to your calibrated scale. See in this totally you can see for your voltage, for the voltage both for AC and DC, it is fed into a calibrated attenuator, and for current we have to pass it through your low shunt resistance. Okay, just make a sharp note on that. Okay, so for your voltage we have to send it to a calibrated attenuator, and for your current we have to send it to a low shunt resistance. Added to that, see for your AC supply, AC current or voltage, we have to send it to a rectifier, for whereas for your DC supply it is directly fed into your analog to digital converter after the this block operation. Okay, fine. So next it is get, you can see the display over here. So these are the basic information regarding your digital multimeter. Hope you're clear with this topic. I believe that I have made clear. So if you have any doubts, please write your questions in the comment section. With this I'll wind up. Thank you.